Well, hello, everybody. Good morning, good afternoon, good evening, good night to everyone, wherever you may be across our absolutely lovely world. I do enjoy saying that. Thanks for joining us live here today for the one and only, really, Serverless Office Hours. It has to be the one and only. We are streaming on the AWS Twitch channel, so welcome if you're joining us from there. And we're also via YouTube on the AWS Events channel, so you're joining us from there. But you probably know where you're joining us from, but just to know the other options if you're on the other kind of stream. This week, we are talking workflow executions. We're talking durable functions, best practices, AI, the whole lot. And two of my favorite friends in the whole world, absolute gurus on these kind of things, Michael Gasch and Eric Johnson. Welcome back, both of you, to Serverless Office Hours.
Hello.
We do have some first-time callers. So, Eric, you may as well go first and introduce yourself for some people who may not know you.
So my name is Eric Johnson. I get the wonderful joy of working on the same team and with Julian Wood. We are basically twins. You can't tell, but we are. So that means I'm a developer advocate, and we speak mostly about serverless. I am based out of Colorado, and love what I do.
Cool, awesome, and Michael, welcome back. And for people who don't know the awesome Michael Gasch, tell us what you do.
Too much praise, Julian. Thank you. I also always love to be on the show. So I'm Michael. I'm a serverless product manager based out of Germany, and my specialty these days is durable functions.
Excellent, fantastic. Now, we have the gurus. That's why we bring them on to Serverless Office Hours. So we are live. Send us your questions, send us your comments. If you are watching the recording in the future, that is also great as well. Thanks so much. This is why we do it live, so you get to answer your questions and comments. We have people all over the world to join us, so please let us know in the comments where you're joining from. That is also awesome. It's literally at the beginning of the day. We've got Peter Smith, who I know is in New Zealand.
Hey, Peter.
Hi, Michael. So welcome back,
Peter.
Peter Smith. Also awesome to have you. We do have some. Oh, seriously, the chat has degenerated quite badly. We do have some AWS serverless DAs as well. We've got a David Boyne. Who's
my God.
Cowboys. We've got Ben Smith who's joined as well, saying
Oh,
it's the gang.
wow.
It can only go up from here, man. So good to see you all.
Good to see
Amazing.
you. He's missing us as well, which is always lovely to see, and it is the dream team. Well, thank you, Ben. We love it, and
Yes.
we have a good best. I'm going to mess that up, but welcome from Chicago. Thanks for joining us. Thanks for joining us as well. Okay, over to you, Michael. Lambda durable functions came out last year. It's been pretty quiet since then, hasn't it?
I don't know. No, I don't think it's been pretty
Not
quiet.
at all.
What do you mean?
My sarcastic, I live in Britain humor went down like a lead balloon. So yeah, it has been on absolute fire with so much going on, the amazing things. So even just as an intro, what are the kind of things you're seeing people build? The weird and wonderful ones. Obviously, we orchestrated a workflow, and that was pretty simple. So maybe just give a sort of quick overview of durable functions for people who may not know, and then cover some use cases.
Let's start there, right? So last year at reInvent, we launched durable functions, Lambda durable functions, which turn Lambda functions on its head, kind of, because we added durability and long-running executions to Lambda, which, as you know, Lambda has been a stateless service with short-lived execution durations. And so before durable functions, if you had use cases that required durability or long-running execution, like payment processes, or even more recently, a lot of these GenAI use cases, you would have to use additional services with Lambda, orchestrators or brokers, message queues, databases for state persistence and coordination. And we noticed this pattern that customers loved building with Lambda, or do love building with Lambda and the tools that they use in the programming language, but then they always had to also reach for other kind of services. And so there was a bit of complexity involved, especially for those people that wanted to stick with the Lambda, within the Lambda experience. And so we launched durable functions, adding these durability capabilities and additional features like long-running executions to Lambda. So you can, by using the durable execution SDK primitives that we offer and that we'll show in the demo, you can extend the execution of a Lambda function to up to 1 year. This doesn't mean the whole function runs for 1 year, which is also probably not something that you want to, but it's when you have cases where you need to wait, or you have a human approval, or these days more agents, that need to call back, and you have fan out cases, all these things we'll talk more about today, then the SDK that we added to Lambda will provide you those primitives in a very easy way to program around. And also, it helps a lot with simplifying the local developer experience. So durable functions are just Lambda functions from a code perspective. And especially when people use coding agents these days, it's just plain TypeScript code with a bit of SDK that we added. And we have local testing, local emulators, we have SAM integration. So I really like the developer experience, and I haven't written any line of code since the launch because the agents do this for me. They are really good at writing these durable functions, and it's just a breeze and catches most of the bugs that you would have just realized after deploying the whole thing. So the whole loop is super short, and customers love that experience, like so much good feedback and excitement around it.
Cool. So just for the coding agents, durable functions is super new. So how would that even be trained in the models? How does that all work?
That's a good question. Yeah, and I think the models are catching up as well. Like we see new models being launched almost every day. But because we were not quite over the last month, we added, well, first of all, updated documentation. So you could literally just point your model to the documentation and say, hey, figure it out. But we also provide Kiro skills. We are part of the MCP serverless plugin. We are in the Anthropic marketplace for the serverless tools, and they were all enhanced with skills or information around durable functions.
Oh, cool. So so you can just plug either MCP servers, skills, Kiro powers, Claude skills, get mixed up. But yeah, in your coding agents, and then it just figures it out. Love it.
Exactly.
And I suppose it's just normal TypeScript code. So yeah, a few little decorators, not quite decorators, but wrapping kind of things, which I'm sure we'll cover.
I thought what was really interesting, I'm going to interrupt here. Nobody asked, but I'm going to say it anyway. So when we were first doing durable functions, this is before we released it. So if you remember Mike back in, and every day I would call Mike and say, I'm confused and help me. And he would help me. But one of the things we would do is just point it at the SDK or a model at the SDK and say, write a steering doc from this. Tell me how, do an introspect on this and just build out a steering doc. And it was really slick how it did it. So in Kiro, we just dropped the steering doc in, and that helped me a lot because this may shock you. And I know that David and Ben are out there, and they know this. I'm not the strongest developer in the world as far as TypeScript or as far as any language, really, honestly. But so it was super helpful.
Cool, awesome. So Michael, just back to use cases. Obviously we're going to talk a bit about agentic stuff because I don't think you can be on a live stream and talk about agents at the moment with yourself. But yeah, just kind of use cases or boring standard things. What people migrating to. What kind of things are people building?
Yeah, we anticipated some use cases that customers told us before or that we were seeing where like these orchestrators were being used. So a very common one is what we call distributed transactions, not to be confused with the computer science notion of distributed transactions. So what we mean here is that typically in a process or in a workload, you need to coordinate across different services like third-party APIs or even internally across some of the APIs. This could be a checkout workflow, it could be a document processing pipeline or file processing, could be a transaction, like literally a payment transaction. And often these workloads involve multiple steps. And you want to make sure that they all complete or none of them, almost like an atomic way. But the problem is because it's not a central database, you don't have a single transaction that you can wrap around. So you have these challenges with distributed systems where you naturally write retries around your code. But if the whole code blows up, you need to also have an orchestrator that wakes up or resurrects your code to continue. And that's the kind of the bread and butter of durable functions. And they are often very short-lived. Couple of seconds or even under a second of these transactions if they go through. But we also have customers, especially in those cases where they're generally short, that have then APIs that they need to retry for up to 6 hours or even a day. Sounds crazy, but if you don't control some of these downstream dependencies, but you're still liable for making sure that the transaction that you're processing is going through, you want to continue and retry. But you don't want to retry. Well, first of all, you can't retry for 6 hours in a Lambda function given the 15-minute timeout, right? But also, if you could, you would just spend money waiting for something. And what Durable Functions offers you is a very simple or elegant way to wrap your business logic in, we call them steps in our SDKs, that have automatic retries. And between the retries, you can, or the function will actually suspend. It will not keep running. And so you can say retry for up to 6 hours and wake up every hour to do the retry, or otherwise escalate to a human. So that's the kind of bread and butter of durable functions. Then we have more long-running kind of things, user onboarding, where someone has to click a link and that could take a week, for example, or even resource provisioning in infrastructure systems or other services. But then lately, and to my surprise, positively, lots of customers adopting or modernizing workloads, existing workloads, or building new ones with GenAI capabilities. This is not to say that everything that they're building is literally an agent. We see a huge variety of existing workloads being added with LLM calls, like just some inference calls in between to do some analysis on a user input, for example, or a document. But then it extends up to, and that's what we'll see in Eric's demo as well, into I have a bunch of agents which you can throw open-ended problems at them, but they need to be controlled in some form. I want to control the concurrency to these agents. I want to make sure that if some agents fail, I have a way to escalate. I want to add some human-in-the-loop approval process to that. Or I even want to validate what the agent comes back with to make sure that what the agent responds is kind of what I'm expecting, this kind of shape. We'll talk more about that. And so we see a lot of new use cases coming in where durable functions are used very much in the agentic space these days. And that's super exciting. I haven't thought that we would see such a quick ramp for those workloads.
Cool. And we'll definitely get on to Eric's demo as soon as we can. But I just want to sort of ask the other question that some people may be asking, why wouldn't I use durable functions, or when is it the wrong use case for something? This is AWS. We love technology. We love AI. The world's going nuts for everything. Everyone gets excited about everything. What are some of the caveats or things you would encourage people to think about before adopting?
Exactly, that's a great question. So in our developer guide, we also have some positioning there and some guidance. One question is, well, I know there's a step function, so I have a workflow system, kind of a visual workflow orchestrator. Should I use durable functions now? Should I migrate all my workflows to durable functions? And there, as always, it depends, because durable functions means you write code or your agent writes code. And so you're still liable for this piece of code that you need to update. There are dependencies to it. You need to think about scaling, even though Lambda scales, right? Your downstream dependency might not. Patching, these kind of things. So whenever you have a requirement where you want to completely be hands-off and super low operational impact, then step functions like this purpose-built workflow orchestration system is still a sweet spot, because you write your workflow once and you don't have to worry about any patching or scaling. The system will handle that for you, right? But then it also has the drawbacks. You need to learn a different service, right? Or you have multiple services that you need to compose and integrate with it. And so this is where we see people swinging between durable functions from a coding approach versus the step functions. Another one is you have super low latency applications like web serving workloads where you need sub 100 millisecond response time, and you don't really need the durability there. You have query handlers, or you have just a single task that the thing is performing, inserting something into a database or sending out a message. Probably not a good use case for durable functions, unless you want to don't want to worry about retry logic, which we'll give you for that. But durable functions has an added latency because of the durability piece that comes with it. So it's always durable, even if you don't use anything of it, because we do some checkpoints, some housekeeping, some observability, so which has an impact there as well.
Perfect, excellent. Eric, I know you've got a demo to show, but just before then, you've obviously been talking to lots of people and doing a lot of building and playing yourself. What kind of things are you hearing from people?
Yeah, so I think one of the things I'm hearing, and Michael and I were talking about this last week, is, and Michael alluded to this, the agentic space is huge for this. I really think so. As I was doing a lot of research on this, it's all I'm hearing is I need to be able to manage my agent. It's really interesting. A lot of times at the first swipe, people are trying to manage agents with agents, right? So we have non-deterministic, orchestrating non-deterministic. and you end up a lot of prompt changing and trying to, a lot of herding cats, right? And so what I hear a lot of people tell me is, look, I just want some kind of handles to hold on to. I want something concrete, something deterministic. And that's where the durable functions come in, as they give that. And Mike already explained all the reasons, but that's what I'm hearing from them is this is something I can say, okay, that didn't work, then do this, rather than trying to kind of get the water, the malleable flow of a non-determined agent to kind of figure that out. And so they really like this. The other thing that I hear a lot about is this, or I hear a lot of excitement about, is this ability to pause code. Look, I'm going to pause it. I'm going to wait, 1, 2, 10 minutes up to 365 days. Manual intervention, other things like that, much like with step functions where we offer that. But I like to stand I've talked about this in a lot of different user groups, conferences, things like that. And I love to ask people, how do you pause code? It's like, well, pause code. How do why would I do that? And so it's a really interesting concept, and folks are really loving that.
Cool, yeah. And I think also, one of the anti-patterns we always had before was, you had a transaction and you chained Lambda functions, this long chain of pain to be able to do those kind of things. The first Lambda function would wait for the second, which would wait for the third. The first would wait for both. Cost you a lot of money, very brittle, something would break. And so I'm also seeing some, workloads with that, where people can still keep those separate Lambda functions to do things, but the coordination is, much simpler and far more robust. Before we get on to yeah,
sorry. It gives us a lot of, because a lot of times we would do this through event-driven, right? We would orchestrate through event-driven, and that's a great model. It's a great pattern. I still just truly believe in it, but there's chaining and worrying about order, worrying about, did something complete and not. Again, it gives us a much more concrete. So the mix of event-driven and this orchestration gives you just super powerful tools in your belt.
Cool,
yeah,
excellent.
And I have lots of thoughts on this as well, Julian. Maybe we can rabbit hole a little bit here on this one. So for the event-driven, as Eric just said, very common use case, super hard to model in an EDA architecture. You get an event, you get a trigger, and now you need to wait for a minute because you're not sure if there's something else arriving or if the state is already updated in the database. You basically have to pause for a minute. Or to coalesce different events that are arriving maybe simultaneously. Durable functions, super easy. Context, wait a minute, an hour, of however you want, and then you move on. Another one on the agentic space where we are seeing also confusion about workflows, or these kind of closed loop agents, if you will, and open-ended or open loop agents where you give them a problem and they go off. That's typically, the latter category is typically what we know from using ChatGPT or Kiro coding agents, right? You just throw a problem at them and they figure it all out. Now, what some people might know, but not everyone, is that there is this harness around the model. It's not like the model does the heavy lifting of you give it some prompt and it figures out something. But the harness around it makes sure that the model moves in the way that you want, that it uses the right things that are approved, that it's allowed to do, right? A simple one is the plan mode. Do plan before you act. And this harness is typically like the Kiro agents, the Claudes, the codexes around the world. And there's a lot of magic and IP in those harnesses. And this is the same what we see in the backend when customers build agents, like agentic applications, where you need to put a lot of guardrails, as Eric said, around this agent. And a tool of, like a really powerful tool is a workflow that you can put around it. And so we often see confusion. Well, I have a dynamic problem. I have like a couple of steps, but I don't really know in which order they should be executed or how many of those. So that is not really a workflow, because in a workflow, you typically have to think upfront of what the steps are. But that's not true, because you can totally use an agent with a workflow, and the agent comes back with a couple of steps or non-steps, and then the workflow executes based on these recommendations. So that's one of the confusions we are seeing, that, oh, I think I have a dynamic problem, and therefore I cannot use a workflow with that. The other one is that, well, I want to use the agents, but now I need to trigger it from a workflow. That's also not true, because you can totally trigger the agent first, and then the agent can actually trigger a workflow. For example, you have an existing process, a Lambda function, or even something very critical in your business that you just don't want to make agentic. So that pattern of agent to workflow, or durable function to agent, like those two kind of sides of the same coin, is also something that is quite obvious when you when you talk about it, but not necessarily when you're not like really deep in that space.
Cool, awesome. Want to get to the demo, but just we do have Luis Arezzo from Colorado. Also likes the Chain of Pain. Well, that came out quickly. I wonder where I remember that from. Chain of Pain is your street countdown name. Previously, we had Higgy Park. Higgy Park is one of our internal AWS absolute gurus in all things AI. So welcome, Higgy. Nice to see you as well. We did have, and we had GD Harmec9 from India. Welcome as well. And we got Aaron P. Walker from Berlin, Germany. Thank you for joining us from Germany. You also asked about the addition of S3 files, support for Lambda. I assume that'll work for durable functions too. We are going to cover that a little bit later, but the awesome Eric has obviously written a blog post about this, which we'll, the link is there as well. So Eric, I've too much chatting and a lot of it's my own fault. So what have we got to show?
So let's bring up my screen here. Hopefully we can see it, and that's big enough. So I'm going to show the architecture of this really quick. And this really goes back to this idea that we were talking about. And I'm going to walk through some of the decisions that I made on this. And actually, let's go ahead. I'm going to kick it off so we can see it in action. Now, this is a Telegram bot. And so we interact through Telegram. Telegram is great. You can create bots. It just works. It's really slick. And so what I'm going to do, this is a content creation. I'm going to start this off, and then I'm going to go back and kind of explain it because it'll go through a lot of different things. But what it's going to do is we're going to say, I want to create a video about, let's see, AWS Lambda durable functions, and of course spelling matters, although that my agents know me well enough that they deal with my spelling. So and we'll go S3 files. So let's say I wanted to do a new video about this. And what it's going to ask me, it's going to go, okay, I'm going to start doing this work. So we're starting the content pipeline for your topics. Hang tight. Now, under the hood, so let's go over here and look really quick. So we're just going to let it sit for a minute, okay? So under the hood, let's go back to the architecture. So the Telegram sent a message to API Gateway, which then invokes a Lambda function. Now, if you know me at all, you're like, Eric, we know you love VTL. Why didn't you just go VTL straight to the orchestrator? And I could have done that, but I had to do a lot of logic because one of the things I'm doing is I'm securing it that I'm the only person that can hit this. So I'm actually extracting the from the body, the user of the Telegram. It has to be on a list and things like that. I'm doing some other logic. So that's my handler. And then it's actually going to call asynchronously and invoke the orchestrator. This is the first durable function right here. It's really the only durable function. Now, I have 5 agents that are going to happen. Yes, I do have. I've got my Diet Dr. Pepper right here. Yeah, I appreciate you caring. So my 5 agents are a research agent, and it has to happen first. Then an outline agent, second, demo code agent, and then we'll draft a script, and then we'll actually run an edit agent. And it's like, well, Eric, why are you breaking these apart? Well, one of the things is I'm using different models at different places. Some that are better at code creation versus some that are better at just creating an outline. I may use something like Nova for simple, summaries, and then get really into, Claude, Opus 4.7 to do some heavy drafting or reviewing. So the different models. And then it's saving all the information to DynamoDB. So what I can do is I'm going to go back here really quick.
So Eric, just to jump in, you've got one Lambda durable function and then multiple other, in effect, tools. I mean, would they be tools? Are the separate Lambda functions, or you call them agents as well? But how would I think about that?
These are all agents. They're running ARM64, Python 3.14, as you can see here, and they're using the Strands agent layer. And so I'm actually using strands in each one. And the reason I'm doing that is so they can interact with the orchestrator. The orchestrator does that loop, and then once it's done, once we get that completion back, then it moves to the next one. So
it's an agent-to-agent architecture rather than agent to tool.
No. The orchestrator is not an agent. The orchestrator is orchestrating the agent. And so it's a deterministic, it's very good to understand that it is a deterministic framework or orchestration that we're invoking these agents one at a time.
Okay. Because I lost that. So you basically got the durable function, which is the workflow saying, agent do this, I'm waiting, agent do this, I'm waiting, agent do this, I'm waiting. Okay, cool.
That's right. And I'll show that code in just a minute. I want to make sure and leave enough time for Mike as well.
Eric, I just had a little remark on the Zoom as well.
Yeah, go ahead.
Because it's easy to glance. You mentioned it, but it's easy to miss what you just said. So for one, while the orchestrator is a durable function, your agents are not, as you called out, right? And they could also run on some other compute. We know we have customers that run them on ECS or Agent Core or even a third-party platform, right? So that's a critical piece here, that you don't need to run this all on a durable function. Those are all not durable functions. And the other one, briefly, the Telegram bot Lambda, which is also a non-durable function, calling the orchestrator, it's literally just calling the Lambda invoke API. So there's no orchestrate or start workflow or something. It's just invoke. And that's the beauty, right? Anything that supports invoke will work with a durable function.
That's also, because that is asynchronous, that Telegram bot is fire and forget. It's going to kick off the orchestrator Lambda function, and then you're not paying for anything waiting.
That's right. So you see right here, it got this back here, right? So that fire and forget is that Lambda responding, hey, I'm starting your pipeline. It's no context or anything, just hang tight. But it's a response. Hey, we knew it happened. Then it's going to feed back some information. And the durable function can talk directly to the Telegram bot, right? So it's going to, through the API, right? And then it's saying, okay, now I'm ready. So the durable function, if we were actually look at it, it's sitting there, pause, it's waiting for me to respond. So I have two options. I can say, I want to review each phase, or just build everything you think I need and go. So we'll do a review each phase for the moment and let it go. All right, so once that goes, so let me go back and we'll let that kind of run in the background. Now, it's not lightning, okay, but it's running. Now, I want to call out on this architecture because I have one of these in an internal tool that, I mean, I could do this locally without ever running it in a Lambda. And I'm sure, I don't see the question, but I'm sure in your head you might be wondering, why are we running this, out here rather than, in an agent locally in a Claude Code or something like that, or a CloudWorks? And the reason for me is, if I want to share this, and I do, if I want to share this across the whole team, rather than me say, hey, go install this, go install this, go install this, it's here's the bot on the Telegram, go. And we can form this. So this needs to be able to scale, right? So going back to what Mike was talking about, each of these are running in a Lambda function. They could run in an Agent Core runtime, but any of them, they're going to scale to handle these. So that's why I'm running, obviously, in the cloud, and I'm adding the security and stuff. So let me go back to the agent real quick. All right, so the agent is actually
not long-running agents. Each agent is going to run
that's right,
way under 15 minutes.
That's right. So right now, so let's say this runs through our entire conversation through the hour. What's really going to happen is I'm going to have maybe a minute and a half, 2 minutes of compute time. Because again, now that it's got my summary, so it's done all the research, it's pulled everything we think, what is AWS Lambda, we'll go through this, it's giving me all the links, here's everything. Now it's asking me, it's paused, there's no billing, nothing's running. So now let's move. I'm going to go ahead and I get a full outlook in S3, by the way.
So Eric, just to look at the architecture diagram, how far have we got? What the orchestrator?
We've done this one. We've done research agent.
Research is right.
Right. Research agent went back. Orchestrator talked to Telegram and shut it all down. Now, once we've responded through Telegram, it's come through here again, and Orchestrator picks it back up and it says, okay, I'm going to go ahead and run outline agent, or it's waiting for those prompts, right? And so, Mike, we were talking about why would I use invoke rather than wait for callback. One of the reasons I did wait for callback is maybe I want to continue it. Let me show code here. Actually, we could have done it either way, and Mike will be the better one to talk about this. But let me go here real quick. So the agent, this is actually the invoke agent and wait, and so. We're going through and this is kind of where all the agents run through the same thing, but we're doing a context.wait for callback. And what this is doing is I'm actually saving a token that it has, and it's gonna have that token stored. And so the agent actually has the token, so it's doing all its work and iteration and getting everything done. Once it's done, it's going to call the Lambda service with this token. However, Mike, you're showing the other one, right? Context.invoke?
Depends on time, but keep going. Yeah.
Okay, right. However, I could also do this with context.invoke, so I don't even have to deal with calling back the service. The Lambda service would automatically just bring it back. This is a case of I'm building these and I'm still learning these. So there's sometimes a better way of doing it, but depending on how you want to build that. But I use the wait for callback, and this is super helpful if you're doing something asynchronously, another service they can't call back in, and it calls back in. But you can see here where it sends the agent or it sends the number over, that's submitter, the wait for callback, and a second here, and looks for callback errors, exceptions. And that's the entire code. And now I've got this repo that I'll post here in a minute. I'm not going to try to talk through the code. Again, Eric's code is a liability, but I'll share this code so you can see it, play around with it, deploy it if you want.
Maybe just a quick note, Eric.
Yeah.
For folks who have not seen the durable function in action. So on line 194, you see the typical Lambda event handler. Oops, sorry. Yeah, there.
Right.
194, right? And so we annotated, because it's a Python, we annotated it with this @durable execution, which marks or injects a durable context to the event handler. So a durable function is basically a Lambda function following the same event handler pattern, but it uses this durable execution SDK when you enable it for durability on function creation. And then you have access to this context, which is an enriched context, if you will, compared to the context a non-durable function has. And that gives you access to these wait for callbacks, steps, waits, and all these primitives. So folks who have just seen the context wait for callback, oh, I didn't know context had this. Well, it now has it with the durable execution SDK.
That's right. It also lets the Lambda service know that this is more than just a regular Lambda function, that we're going to have checkpoints. We're going to have, those kinds of things. So a lot going on here. Okay.
And maybe one remark on the wait for callback and when should I use context invoke. And I'm glad you're showing, actually, Eric, that you're showing the wait for callback, because context invoke is a syntactic sugar that we added to the context if you want to do these function chaining or calling another Lambda function, which could be an agent, could be non-agent, could be a durable function, what you want to. But if your agent runs on not a Lambda, different compute, like agent core or ECS, then wait for callback is typically the pattern, because you just give the callback handle to the agent and then the agent completes the callback going back. We added additional APIs to the Lambda API to complete callbacks.
It's really interesting because forever, and Julian can attest to this, in all my years here at AWS, someone said, oh, a Lambda calling a Lambda. You go, no, that's an anti-pattern. Well, it's not in this case, because all the durability is being built in, the retry and those kinds of things. You can see here, even this is the wait for callback, but I'm passing a config where I'm setting my timeout, right? So I'm saying, hey, if I don't get a response back in 15 minutes, then we've got a problem. And that makes sense because, it's calling a Lambda function that's going to churn it can only churn up to 15 minutes. If I hit this, and this is a great call out, if I'm hitting this repeatedly, then it's time to look for another compute for my agent, right? It's time to say, okay, let's look at maybe using agent core, running ECS or something like that. Okay, so we can go through and finish this, but I think that's what I'm going to show for the moment. Basically, if I go through and I say, hey, I want to iterate on this, let's make sure this is Python. Well, then what it's going to do is it's going to know, let's go back to the same step. So there's logic written in the code that says, okay, we need to work on that same outline. And so it's let it know, and so it's actually reset back there. So what I did with that is, rather than moving on, we're back in the outline, and then we can continue all the way through. And with that, I'm going to pass it back to Julian, unless we have some questions.
Yeah, well, Louise has asked again, how does that Python decorator define the state? Is that just because you've imported the SDK right at the top and using a normal Python decorator, or is there more to it?
Let Mike answer that.
Yep. So when you create a Lambda, a durable function, you go through the normal Lambda create flow, and then in the console, there's a new checkbox called durable execution. In the API, it's a new parameter that you pass, which marks the function for durable execution mode. And then what the developer needs to do in the code that we see here in Python, for example, with the decorator, you import our SDK for durable execution in Python, and then it basically upgrades this context that we are seeing there by injecting some client. Consider the context here a client and SDK, which allows you to checkpoint and replay and suspend execution. But you don't see any checkpoint, suspend, replay here because we abstracted this into these patterns like steps and waits or callbacks. And that is how then the state is managed behind the scenes.
It's really just the format of a specific language. In TypeScript, it would be a wrapper, versus a decorator. But yes, yep. So
in fact, just why we're talking languages, we talked about TypeScript beforehand, Python. I know there's also a SDK available in Java. Anything else? So yeah, what languages can you write durable functions in?
Yeah, Java just came out today. Well, we had a preview for Java, but we launched GA today. So
cool.
Let's have a party. And that was a big one because Java is a very popular language in enterprises, also at Amazon. So there was lots of interest in Java for durable functions. And now you can have the same idiomatic experience that you're used to when writing Java code, just with these new primitives that we've seen, waits and steps and so on. And fully testing, we have a local test kit for Java, and we support Java 17 and upwards. We also have lots of interest in other languages, Go, .NET, Rust, even someone from the community wrote a Rust SDK, a prototype there. But we haven't decided yet which language we want to take next. This depends on community feedback because we want to make it feel right for the community. We're not going to templatize and just spit out language code. So we are really carefully crafting those SDKs and currently monitoring interest in other languages.
Cool. Because the AWS Lambda runtime is open source, it's available on GitHub. I think it's AWS Lambda-roadmap, if I'm not mistaken. But yeah, if you search for GitHub for that as well. So yeah, in fact, look through all of the Lambda roadmap, and Michael and the rest of the product managers are actively looking at that, starting discussions and getting your feedback. So that's a great way to be able to steer the future of Lambda.
So just as a quick tag here, while they were talking, you could see I was going through the console. This is the actual function running. This is the version of the function. Took me a few times to get it right. Again, Eric's code, liability, 91. There we go. But it's running here. And so you have your input. You can see what's coming in. Here's my input. And then you can follow it through all the steps. And there's a lot of other information you can find in the console as well.
I think, Eric, if you click on one of these maybe steps or so, it's really useful, the overview that we are getting here, because depending on if something is returned, I'm not sure if this step or callback, maybe you have a step which returns something.
Yeah, let me.
This one.
Yeah.
Is there an output to it? Okay, this was
an
empty output.
I'll find one.
But basically, this view helps then operators to troubleshoot, obviously, see if something has failed. Oh yeah, there we see, and it was approved. And also see what these steps have checkpointed behind the scenes, how long they run. You can also look at the events that were emitted behind the scenes, whether the function completed or suspended. So this dashboard is pretty rich. You don't have logs in there. Okay, yeah, you would also see the logs.
It's still loading, yeah. So there you go. You see the event history as well. So, all right.
Nice.
So currently we've gone through, 2 out of the, 5 steps, or 2 of the 5 agents have run, or whatever, how many, maybe there's got further on. And this is what you're looking at here, is you're looking at the orchestrator function, and it's gone out and called one agent, come back, gone out and called another agent, come back, and you're seeing that. And you can see any retries, see the input, see the output, in a similar way that you can, which is helpful in step functions, that you see something go into the state machine and out of the state, or into the individual steps of the state machine and out. And so, I think it's a nice, also visual merging of that, I think, good developer experience between the two.
Yeah, I would tell you Telegram may not be the easiest to see code in, but here's my code examples. So it's gone and created all those code examples and written it all up. There's a lot of them. And it's interesting, you're like, well, this isn't really a way I'd want to interact with the model. But think about how many people are doing things with their phones, taking off an agent and then coming back to it later. Let me just check on my agent what's it's doing. That was the whole reason I built this. Where this really came out of is I got a call from somebody saying, hey, can we do event-driven agents? I was like, yeah, and for, Ben and Dave, you're on there, and Julian, we've been doing this for, it's like, yeah, we've been doing event-driven forever. I literally was like, yeah, we can do that. And this is an event-driven agent, right? We're making a request. We can do this from a button, from a file drop, from a light switch, whatever. But they're event-driven agents that only run when we need to and sit around. So this is an example of that. So, like I said, I'll post the repo shortly.
If you want some other examples, the New Stack podcast, which is a fantastic podcast talking about lots of modern software development, recently interviewed Claire Ligori. Now, Claire Ligori is an AWS super duper absolute guru, and she's actually on the MCP steering committee. So she's literally AWS's representative there to help steer MCP to make sure that it's awesome for developers. And she's an absolute brilliant developer. And she had this awesome idea about thinking about agents in an event-driven architecture way. And I thought about it before, but she articulated it so well. So that's why I'm encouraging you to go and search up and look at the podcast. But she said, there are so many agents that spend their life waiting for things or reacting for things, or you need a file to be uploaded. And she said, think of a webhook. There are going to be so many other kind of things that an agent's going to kick off a tool or kick off another agent or do something. And it's normal, very software architecture way as well. You're going to have a web to call back, and so you're going to want that agent to be able to then react to the webhook and then carry on or go down a different path or do different kind of things. So in a way, it's the same architecture as we've had all before. You call something, you wait for a response back, something calls you, and now you can build that all within either a durable function or with Strands SDK or anyway, and have this really impressive way that you can have this event-driven agents that can react to these events. So I thought I'd give Claire a shout out because she articulated it way better than my rambling.
Well, this could be, yes, I'm doing it to a content creation because that's what was on the mind, but this could be applied to so many things. What kind of agents do you need to happen? What order do you need to happen? How can they help your job? So there's a lot you can do here.
Eric, we glanced over the S3 announcement, even though you put it in here in your content creation pipeline. But let's talk a bit about the announcement itself, the S3 files announcement, and then how it applies to these agentic use cases with durable functions, because you also wrote a blog post about that.
Yeah. So the example, and I'll post that one as well. In fact, it's already in the links there. We're just watching there. Our job is done.
Just quickly, that's basically come back with a video script that you can then use to create a video.
That's right. Yeah, the pipeline's complete. Here's all the artifacts.
About our jobs here.
You should.
Taking our jobs.
Yeah, this right here is not real. This is AI generated. So now, okay. So let me go back to the S3 here. I'm gonna bring this out. So the S3 is basically what it's allowing you to do is mount an S3 as a file system in the Lambda, which is super helpful because and we used to be able to do this. We can do this with the FS, but it's not the same type of mounting. It's a POSIX, and that's, I don't even know what POSIX means, but it's a POSIX file system, and you can mount that. And so rather than me I'm going to talk about what this means to durable functions, rather than me having to call an S3 and grab the data, which is quick, it works, it's already there. So when the Lambda comes up, / whatever, that S3 file is already there. I can read from it, I can write to it, and then the next stage can read and write. So if I'm orchestrating multiple Lambda functions, I'm no longer having to pass that state. Although I could do that in a durable function, what happens when that file is huge? What happens when I'm dealing with monstrous files that I need to grab and write and read from? Well, instead of me passing that along and paying for the extra time or compute or whatever, it's always there available in the S3 bucket. And I can say, okay, do the first work. And the example I have on that one, and I can pull that up in a little bit, is it actually grabs a repo and writes it to the S3 bucket, and then it kicks off 2 agents. One does a security check on it, the other does a style check, and it does them in parallel at the same time. That's what parallel means. And it does at the same time, and it can read. So one writes it and the other 2 read from it, and then they write their reports back to the S3 bucket, and then somewhere else I can grab it from a client. I can read it from an EC2 instance. And so it makes it super powerful for passing that around. I'll keep going, but Mike, did that help?
Absolutely, exactly. Like this, like shared state between the agents or even between your execution, which addresses the problem of large files, but also the latency of copying stuff around. And this was in the original S3 block, also one of the use cases that why would you pass data around if you can share it?
Yeah, and this whole S3 files, I suggest people take a look at that as well, because there's some basically, we've been working at this for many years because there's some serious hardcore architecture trade-offs to think about this as well. Because S3 is object storage, and it's deliberately not file storage because objects are, just massive. Objects can be huge. The namespaces can be huge. Well, it's not namespaces, but just so much data that can go that doesn't work for a file system. But obviously, you want to be able to do files in the same kind of way. So actually how S3 works, how S3 files works, is it's sort of an NFS/EFS shim in front of S3 that acts as a bit of a cache for reads and then flushes write data back to S3 in the backing store. And this is, well, I think the architecture which I was reading about is super clever, because it's not the worst. It's not the worst of both worlds where it's mashing these things together. It's a slightly different architectural way of doing it. It's not for everything. So, there's certainly going to be cost considerations of it, particularly if you're reading and writing a lot of small files. So look at it as well. But it is amazing that now you can have your S3 object store, and you can share it, particularly with something like Lambda, which doesn't have shared state natively. And now you could have 1,000 Lambda functions concurrently, all connecting to the same EFS mount to be able to connect that, or S3 files, without having to manually copy or even stream data from S3 for each invoke. So that is super good. And Eric showed up. He's got a blog, which is all right, writing about it as well. And then in the chat as well about writing event-driven agents as well. And the other thing I just wanted to show is, that MCP server with Claire Liguri, that is the new stack link to which Jeffrey, our awesome producer, helpfully put in the chat as well.
Julian, there was an amazing blog that Andy Warfield, he worked on this, on Bruno's. If you can find this one,
yes,
it was on Bruno's blog post.
And Andy Warfield, if anyone even we can't go on our heroes as well, never mind Werner. But Andy Warfield is one of our distinguished engineers who works in S3. And he was only one of the inventors of the Zen hypervisor all those years ago. So he's awesome. So I will find that, and it's certainly for all the nerd geeks. It's worth finding. It's worth reading about, because just cool history. Okay, so where from here? We've I know, Michael, you maybe, if we've got time, had another kind of demo. Obviously, want to talk about futures and things like that.
Yes.
Where next do we need to head to?
I'll maybe take 3 minutes to show not an end-to-end demo, but give a community member a shout out, which is Gunnar Gorosh. A lot of people know him. Yes. And he built this amazing, he did a lot of blogs and demos on Drupal functions. And I used his demo in a lot of conversations because it's more credible if it comes from the community than if I would build it. And I found it actually a really nice example. And it showcases this, like, I have a dynamic problem. I don't really know upfront where the path is, where the agents are taking me, but I still want some control around it. So it addressed this concern that a lot of customers that I was talking to, they were building agents had with, I don't think I can use a workflow for my dynamic problem. So maybe I should just show some code from Gunnar's example, and then we can also show the full repo to that for if people want to dive in. Is that okay?
Absolutely. And here,
that is okay.
Anything from Gunnar is okay, yeah. And just AWS producer Jeff, who's awesome, has put that Andy Warfield thing. So yes, super nerdy, all about the history of S3 files and the challenges and opportunities that have done. So back to you, Michael.
Cool. Did you pull me up?
No, I have now. There we go.
Well, let me show if you can see my screen.
Yes, we can see your screen. The multi-agent purchasing coordinator.
Exactly. So this is Gunnar's repo here on GitHub, just so we have the link. I'm gonna go into the code. So what his code is doing, somewhat similar to Eric's, is he has a planning phase. In fact, he is using strands in durable functions for a planning phase, and then he's fanning out using the parallel approach that we also have seen with Eric into other non-durable Lambda functions. They also run strands, but he's using context invoke. I'm not going to focus on this invoke because we talked about this earlier. When should you use context invoke versus wait for callback? So that's a kind of a style preference. But I want to focus on this, what the planning agent is doing here. So this is the TypeScript example. And so we have this wrapper in a TypeScript durable function where we wrap the event handler in a durable execution handler, which then gives us access to the durable context that we've seen in Eric's part.
Michael, do you mind if we just zoom in a bit?
I can. Yeah, let me. Okay, so is this better?
One more if you can. Thank you.
Okay.
Michael's probably got this big screen at home. He's like, "Oh my word, that looks enormous."
Yeah, it's basically I see one line now. No, it's okay. So so we have access to the context, and here's an interesting thing he's already doing, where he's kind of harnessing a little bit his agents because he wants to make sure that if a particular purchase is made, and that could be because it's a price thing or a very sensitive thing or whatever, or based on a customer, that he wants to have a human approval in the step. So he's deterministically taking from the event whether an approval is required or not. So, right? So that's the first kind of thing where we have some control around the model, even if the model says, oh, I don't think there's an approval required here, we can enforce it from the outside as a payload, for example, in the event. Then he's using the context logger, which is good because it gives you this like rich semantics, shows up in the durable execution tab. It's replay aware, so it won't be printed on replays if the function wakes up, and so on. And then he has the planning phase. And this is this step here, or creating the analysis plan. And so with this step, what he's doing, and he basically creates a tool, right? He's passing schemas, which is very important. And then he's constructing an agent. This is all still within the step. So you won't see it right now because I'm zooming in so much, but this is all inside the same step that we are seeing. So he's creating a tool, constructing the schema for this, creating an agent, invoking the agent synchronously from the step in the durable function. And then what this agent is supposed to do, it's supposed to come back based on the input payload of, I think you need a couple of agents here, research agents like that we've seen with Eric. So while it's not known upfront how many agents are required, he's again harnessing the agent into, or the response from the agent into a shape that he's expecting. Like, give me the agent name and give me the prompt that I'm supposed to be using here. So he's putting some guardrails and control already around this with the single step. And then once he has the plan, let me scroll down. So this is then phase 2. So once this step here is completed, he moves into the phase 2, where he's now parallelizing the work or fanning out into multiple agents. And because he has the plan, which he checked, verified, or he's checking and verifying and also controlling with the input schema that he's providing to the agents, he can now iterate over this plan and the specialists in that one. This is a plain map inside, like this is a TypeScript map function that he's using here. And then he's passing a name for the individual step. So he sees the agent actually in the planner agent or whatever in the durable execution overview and in the history. And then he's also passing the prompt into the system. Oops, sorry, that's here, what he's passing. And in this case, he's using the context invoke, where he's calling a Lambda function that he's also getting from the specialists map. So he has all this information that is partially set up front, like the specialist name, and partially came back from the plan, where the plan said, for this, you need these 3 agents and this kind of prompt that came back. And that's, I think, very powerful because you still get this a very dynamic agentic experience by the agent figuring out which kind of specialist needs to be called, but you're constraining it into the set of specialists that are allowed, including if an escalation is needed to a human or login operator, either because this flag was set that we saw earlier, like this event flag of approval needed. Where was it? Sorry, scrolling back. Either because of this, or some agent might not be available, or some agent might time out and not even respond. How do you handle that? Again, that's handled in his code here, where he escalates with try-catch steps and then escalates it to a human, basically flagging, hey, this agent didn't respond, so maybe that's something you want to take into consideration as well. So the whole demo is available on his GitHub repo, and I really like it because it brings back this point of orchestration and still solving dynamic problems.
I've got lots of research to do. As usual, each day goes by, more things are happening, and I've got to learn. So, Gunnar, thank you very much. We super appreciate you.
Absolutely.
Bringing the good stuff. Our title includes futures at the end. So anything else, or we're covering futures, or Michael is spilling all of the beans of the whole roadmap, everything for the next 5 years, correct?
Absolutely not. So yeah, I mean, let's talk a bit about short term. Where are we going short term with this? And also what we are seeing.
Well, short term today is Java SDK.
Exactly.
So even though that's slightly in the past,
It's kind of, So we launched Java SDK today as general availability. So that's a big milestone because it unlocks Java, like this massive community, to durable functions. Second, we are expanding in further regions. So expect in the next days announcements around more commercial regions where durable functions will be available. Will probably be done in almost all commercial regions. So we're rolling out. We are already in the big ones. But we are filling the blanks for those who need like more governance and control of where to place these durable functions. Then also part of the Lambda roadmap that you mentioned earlier, Julian, is we are working on customer managed key support. Today, the Lambda functions support customer managed keys already, KMS keys from AWS. You can set them on a durable function, but for the durable state that we checkpoint and persist, that is using an AWS-owned key to encrypt the state. So the state is encrypted. It's just not encrypted with a custom key that a user can provide. We're working on that, hopefully also like this quarter, that we can ship customer managed key support, often used in banking, financial kind of, or like regulated industries. We are also looking into improving the operator experience, something like deleting individual state of an execution, pausing and resuming executions. For example, you have a maintenance, or your retry loop is stuck because there's a downstream dependency which you need to fix or someone else needs to fix. So instead of keeping to retry, you can actually then potentially pause the execution and resume it at a later point without losing the history and the state and the progress that the function made. So this is something we're looking into. And another pattern that we are also looking into, again, no commitments yet, but we noticed this, and I was super surprised. We have this context parallel that you saw in Eric's demo as well, like this pattern of parallelizing work. And we thought this is probably more for like very advanced use cases, some people who are really deep into durable functions, but no, everyone uses it because it's a basic primitive
every day
in the language. Every day, right?
Yeah.
So we made it so easy to use that at some point you're also hitting the limits, because let's say you iterate, you get an object in an S3 bucket that has 10,000 lines, and you just, let's parallelize to whatever, 10,000. Durable functions has some limits that we put in place for each execution. And with uncautious parallelism, you can easily hit those limits. So we are first evaluating increasing those limits, but then there's always a ceiling. There's also a ceiling that we want to put in place to guard customers against cost explosion and so on, or kind of out of control executions. But there is this pattern of highly concurrent parallel work, and we have the supercomputer. Lambda is the supercomputer. And context parallel kind of is the first step in harnessing the supercomputer in a very easy way. So easy that it's not really hitting the scale that we want to, and that's something we are also looking into.
I mean, things like batching as well, would that be a consideration?
Totally, yeah. I mean, there are these workarounds, right? You can batch, you can fan out and use sub-invocations and all. Like, we have some tricks to work around these limits, but we want to make it easy. Like, it should literally be the context parallel, and then without having to think about these like limits.
Cool. Excellent. Exciting stuff. I love all the innovation and the excitement. Michael, as a product manager, you've birthed durable functions and done an awesome job over the years, because it's a different thing. It's you've had to teach Eric and myself as well, even the concepts and what of it. And durable executions, I think, is such a powerful, important thing in the industry, and it's awesome that you've been the one to bring it to Lambda. So thank you very much.
Great team.
That's about time. Thank you, everybody, for joining. Thank you for all the questions and the comments in the chat as well. Always useful, letting us know where you are. Eric and Michael, our gurus for durable functions this week. Thanks so much. We will be back same time, same place next week. I'm sure we'll do more durable functions in the future. Please let us know, and we'll get in touch with new kind of serverless office hours things you'd love to see. And even if you want to maybe share something that you've built as well, that'll be awesome. Goodbye, everybody. See you next week.
Thanks all.